Alright. Today's class is not really about the mathematics or whatever. It's all about the writing skills on the programming side. Okay, this is very important because if you don't understand this, I don't think so you can write your program. Okay, now we are going to learn about this one, the program control. Okay, you can turn on your PC, get ready for the codes. So, every time you want to write something, your programming, you normally will look at this algorithm or whatever flowchart. Since your C++ or whatever programming that you're going to use it here, or microcontroller, or your FYP, all will help this one. This is the basic skills. Basic skills for programming. Right? So this is quite norm for you if you learn C++ last time. This is the flowchart. You have to know that from this flowchart, where you should use, what you should choose, what type of flowchart, what type of shape that you need to use. Okay? So the program control is the code that control your programming. So look at it one by one. This is a normal one, if-else statement. Remember, if you have if, you have else. If you have then. This is all the algorithm or the sequence of the programming. Alright? But C++ is very easy because you can just read the program. If else is in English. In Microprocessor side, it does not really have this if else. Microprocessor will have a mnemonic or its own code syntax. So you have to learn. Okay? So what we are going to learn here is today is about the branching. Branching means you can jump anywhere from your program based on the branch. Okay? You have the conditional branch. Conditional means berkeadaan. There's something that you have condition, then you can jump. Unconditional, without condition. Jump is jumping only. Subroutine call is just like a function, subroutine. And the last one is return to the program. So this is the things that you're going to learn today. Okay, this is the syntax normally. Alright, just look at here first. Which slide I'm going to skip is this one. This one I'm going to skip. Skip first. This one I'm going to skip, but you just need to remember this BRA. BRA means branch. Okay, branch. You look at the program. This one I'm going to skip. This one I'm going to skip. This one I'm going to skip. Skip. No, this one is going to skip. So just now we have branch. We have BRA. BRA. Now we have JMP. JMP means jump. This is just for first. Now we are looking about conditional branch. Okay? Conditional branch means it will require to check the status before it can branch or jump. Branch means it will need to go through to the other lines. Okay, branch. The first one is the BRA. BRA is a direct branch. BRA is broad, that one. This is direct branch. Branch means dalam bahasa Malaysia cabang. You can go somewhere. It's a branch, branching. Okay. So example, this branch for the conditional one is BCC. Okay, let's look at another one. So you have a lot of them. But the thing is, you learned last time about a status register, the C, N, Z, V, N. So this is all the condition. That's why we have to learn the status register. Okay, first, Alright. So this is all the 14 possibilities of conditional branch. This is the command. This is the syntax. So how to apply it? How to apply it? Let's write one program first. Let's run again the program for the LED. Okay, write down this one again. If you have, keep this one. Write down this one first. Okay, now you can see there's a bra, there's the branch, there's a BFE. So write down first. Write down the code. Last time we only run a few only for the algorithm. Now it's the complete program. Origin 1000. Now you have to start labeling your code. Make sure it's a tag. Make sure the color is correct. Okay, what do you see new things over here compared to the previous lectures that we have? New codings, new syntax that we have to learn today. Example here is this one, JSR. JSR means jump to subroutine. It's like function jumping. JSR means jump to subroutine. Okay, this is quite a new one for you. Okay, the first row here, we know that we have three sections. The first one is labeling. This is the syntax, and the last one is the comment. Remember that. So this is very important. This is like the names of your lines. Okay, this loop It's any names that you can put. It's anything, but you have to understand. Okay? Look, this lines is for this loop. This is the lines. Okay? Then you look another one. This is BRA, branch, bra loop. Means that it's going to branch to the loop. So look first, then we have to do the simulation. And then you have this one. This is basically a function. It's sort of a function. This function is going to give you a delay. So if you can compile it now, compile your program, view your hardware, and look at the results for the LED. Okay, again, compile it. You can compile this one, make sure there's no errors, execute, view this one, the hardware. Okay, and then you can play the command. Play means that you can run consistently, continuously. You hit this play button. Then you have to look at the results here. Why it's very slow? Then you can see my LED is blinking by quite a long delay. You just look at this small. Now it's blinking to the other side. So it's okay, I want to make it faster. So you can change the value here. Which is I already changed for you. I do not for you, it's okay. So I play again. View, hardware, and run it. It's roughly 1 second. You can get the same one? Do you get the same result? Anybody get the real different result? This is a basic stuff. Every time you do programming, the first one last time is like Hello World. Hello World is in C++. The first programming things that you have to learn is Hello World. For this hardware stuff, you have to start learning from the LED. This is the basic stuff. So how to turn on the LED I teach you before, just to turn on. Now this one is not only turn on. This is a controlling how long the LED blink. Okay? So anybody get different result? Semua dapat the same result too. So I can proceed with the simulator. Is that sama? Why it's not blinking? Something is wrong. Find out why it's not blinking. Blinking or blinking or it's not blinking. Look at the result. Is it blinking? That one is not blinking. And this one is not blinking. Blinking or sorry? Very fast is because your PC is faster. No problem with that. If your PC has a faster CPU compared to mine, that is nice for you. So the process is much faster. So you have your LED blinking much faster. Don't worry about that. So if you want to slow down your blinking, you can add more values to the value just now that I changed. You can add more values. You can increase the value. Just now, you can increase the value. This is not blinking. Make sure you blinking first. Is that blinking or not? If you want to delay your blinking, you can change this value to higher numbers. This is what? This is around 384,000. You can just add maybe 900,000. Just change the number, it's okay, no problem. Maybe this one from 3 to 9. Compile again, look at the result. You must have is blinking first before I proceed. Is it blinking? Is it slower? Slower. So you add more numbers, you get higher numbers, it's getting slower. Just add maybe higher numbers. Is it thinking? How many people still not yet thinking? Okay, make sure you're thinking first. I will not proceed before you thinking. Try to figure out. It's not thinking. Not blinking? Half of you is already blinking, so the code is correct. So anything else that you miss? When you write the program, make sure that you have the right justification here, so much easier for you to debug. You just simply write down. Use that. Make sure that you have very justified. Change it, correct. So, few more people still not thinking. Origin 1000, loop, then tab. You have to do tab. Loop.by, hash $0 and E00010. Jump to subroutine delay, book.by, hash $F0, E00010, jump to subroutine delay, branch loop, you should stick one loop here, delay, book.log, hash 84614, or this is a number that can change to D6. And then minus up sub.log, it one from D6. Branch not equal del1. Return to subroutine and end. How many else of you still not thinking? Is that thinking? That one thinking. Thinking? Seorang yang tak banyak yang mana cepat. My one is blinking. Blinking tak ni? But this way you can change any number. This one is okay. What? Kalau you tak ni lagi tak nampak, you tak 9 pada 984 tak nampak. Ya, tunjuk yang lain. So you change the value here. You just change here. You just add another, make it higher. Doesn't matter. That's a variable. You just change this one. This value you can change to make the delay higher. You can just change it to 9,000, 900,000. Don't exactly follow this one. This is just a variable. number. This is quite fast. Okay, one more. Dapat? Okay, the program now. Okay, remember that last time when we learned about the algorithm of all the functions, arithmetic, blah blah blah, we use this one, right? Line by line. So this button is to run your program continuously. Last time we used one by one to look at the results. But now you know that if you hit this button, the program will always continuously run forever until you stop it. You can stop your program by using this one. Reload again. Stop this one. Okay, then now we look at one by one. Okay, understand this? So you can stop this one, put here, refresh again. Now you stop. Okay. Now we have to go one by one, understand the code. Okay, the original code is like this. Okay, look carefully here. This is your code. Try to understand, bear with me, this one. It's not that easy. This is your code. When you hit the play button, this code will run continuously until you stop it. So this command is to trace one by one. Now, you know that this program is basically to turn on the LED for a few delay and off it for a few delay. It involves subroutine and branching. Last time we just learned about that, very simple. We just run one thing done. Now you have to learn how to do branching. That's why they call it program control. Okay, now look at the first one. Again, origin 1000 is for my program, doesn't matter. Now I label this one, the name is loop. I label it. You can put any name, doesn't matter. But you have to use the same name. Example here, loop here is for this branch loop, will be the same one. You cannot use this one, loop 1, this is loop. It will not branch to that loop. This one is referring to this loop. Okay, now look at this one. This label loop, just a label name. The command here is move.byte hash $0f to E00010. This is mapped to the LED. Look at the hardware just now. The hardware value is E00010, which is the same one like this. Means you are sending a byte to the memory, which is this map to this one LED. Now you are sending 0F. Okay, move that byte 0F means 0 is equivalent to 0000. F is equivalent to 1111. So what does it mean? If you are move that byte 0F, this value to E001 means that it's going to send something to the LED. 0 means off, there's no voltage. 1 is 5 volt, around 5 volt, then you're going to turn on your LED. So right now, my command here is going to turn on the LED for this particular spec. There's no here, will be 0001111. So it's okay, I reset it back, no problem. Okay, I want to show the first one. So I reset the whole thing, I compile again. By default here is all on, correct? When I start my program, it's all on by default. So now the first command says move dot byte 0F to the LED. So now I move once. Don't play the program. You just can use this button again to run it. Run this one. You can see now your program go to the particular and turn off and turn on the LED. This one you understand? Understand? Very simple this one. Now it's going to move to the next command. Next command is jump to subroutine. JSR means you have to jump. You must jump. You jump, I jump. You never watch Titanic, right? Titanic is not your time. Titanic is my time. Jump to subroutine delay. This is another name. This name is basically this one. Understand? It's the same name, So if you hit this button again, one time only, it will jump to the delay. It will jump here. Okay, looks like it will go down. It will go down. Correct. My command says you have to jump to subroutine delay. So you try to find out the label delay. So this is the one. So what does it do?